moon is not exactly on the same line that we have with the sun. So the Earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that, A, it's near sunset. It's also the fact that Europe doesn't get as many just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus, with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds. So that's a very long one. Great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so?
Yes.
So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you, Joy.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is, it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see it's twilight. And the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Emir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Emir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because, as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we're going to be imaging the solar corona with an instrument that has 4 cameras on board with observations ranging from visible light through near infrared all the way to the mid-wave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the corona that we're still trying to understand, especially in these infrared wavelengths where we don't have a lot of observations. And all of this will also help us to understand, of course, the sources of space weather that affect us here on Earth.
And so I know you flew this experiment and a similar one during the 2024 and 2017 total solar eclipses. What did you learn from those eclipses? And are you making any changes to your experiment for this eclipse?
In 2017, our first attempt at this kind of observation, we didn't even know what we were going to see. And measuring in the midwave infrared revealed new observations and new measurements that I think opened up the possibilities of lots of future experiments to try to better understand this emission from the sun. In 2024, we flew an upgraded instrument, the same one that's flying this year. It has 4 cameras measuring across 9 different wavelength bands. And we learned quite a lot, although we're still analyzing that data. So I don't have any results to share with you right now, except to say that we saw some amazing structures, and it'll be very interesting once we complete our analysis.
Yeah, I'm looking forward.
For this year, we're flying the same... Oh, sorry, go ahead.
No, go ahead.
For this year, we're flying the same instrument, and we're not making any changes to it from 2024, except that we're applying all of the lessons that we learned from the prior flights including being able to fine-tune the observing time and the observing procedures. And of course, we also now have our data analysis pipeline that's already made from 2024, which will allow us to combine this data with the data from 2 years ago to make new scientific measurements much faster than we were able to do in the past.
Thank you so much, Amir. I know the plane is about to be capturing the eclipse in about 13 to 14 minutes, so best of luck out there, and thank you so much for joining us.
It's my pleasure. Thanks so much.
So let's take a look at the telescope views right now. The partial solar eclipse has just begun in Spain. You can see a little slither of the sun that's been cut off on the one of the sides. The moon has just started to move in front, and it'll take roughly an hour or so before it completely covers the bright disk of the sun. Thank you again to our partners for these beautiful telescope views of the solar eclipse. We're about 10 minutes away from totality in Reykjavik, Iceland. The telescope views there are cloudy at the moment, but what we're seeing in front of us are views from Spain, and hopefully the skies stay clear for Spain. And fingers crossed, that is what we want for a total solar eclipse, is clear skies. So before totality comes, we have a few minutes to show you different types of science NASA has been conducting in Iceland for years. Iceland is a great place for astronaut training due to its terrain. A few years ago, the Artemis II crew and the science team spent some time there to prepare for the Artemis II mission. Let's learn more.
Iceland is a really wonderful place. It's a great place of interest for geologists, but it's also a wonderful analog. On Artemis, we'll visit the lunar South Pole, we'll make observations from orbit, and we have a whole new set of science questions that we hope that Artemis astronauts will help us answer for the Moon and Mars, which are, of course, planetary bodies we're really excited about for human spaceflight. Specifically for the Moon, we have features here in Iceland that are geologically relevant to the Moon and also just have a sense of scale and a sense of identity that really mimic what we know the lunar surface looks like. There's a reason Apollo astronauts trained here, and there's a reason we're bringing Artemis crew here now. This is just a really wonderful place to learn about processes that shape the Moon and to really understand what it feels like and what it takes to actually navigate and do an EVA or a spacewalk on the lunar surface.
In Iceland, we are doing field work. We're training crew members. This is a key location for training for Artemis crews. Here we see in real time volcanic features that were created not long ago. It's a real special place for doing training for geology.
I'm here in Iceland training the Artemis II crew in geology. There's really transformational science that we can learn by getting boots back on the moon, getting samples back, and being able to do field geology with trained astronauts on the surface, making observations that only they can make from that perspective.
Everybody start to see maybe softball size, like.
It's a fantastic place here in Iceland to be able to train geology. Also, navigation skills are another big component of what we're doing out here in a beautiful environment like this, out here camping in the highlands of Iceland.
Wow, what an office to work in. So later on in our coverage, we're going to be taking a closer look at the student ballooning experiments as well. And that's been taking place in Iceland for the past 24 hours. But now we're going to be chatting with Marie Henderson, who is the Artemis II Lunar Science Deputy Lead. She has experience training in Iceland and has a key role in the Artemis II lunar flyby data collection. Marie, thank you so much for joining us.
Thank you so much for having me today.
So during the Artemis II mission, the astronauts were lucky enough to see a total solar eclipse from space. Not to be corny, but that's what I call sun and moon joy. Was that something that was planned from your side?
We knew that it was a possibility that we could have a solar eclipse during our lunar flyby. So months before, we prepared our lunar imaging procedures, some of that based on what we learned during the Apollo program, but also some that we learned from imaging that took place during the 2024 solar eclipse. And so we used that to prepare our cameras, but also once we realized we were coming up on a launch day, especially in April, where there was that possibility, we had to go back and we had extra time to train the crew on what they were going to be seeing during this eclipse. And
No, ya, pero es que había un señor en medio. Estoy. ¿Estás haciendo? ¿Te puedo ver, Guillén?
Because this will be a new, unique viewing orientation as well.
Wow, what an exciting few milestones to look forward to. Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
So if you've just joined us, take a look at these maps that we're showing you right now that's showing the path of the moon's shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villabado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps were made by my colleague Annie Wright, who used various NASA satellite data to create super accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Corrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well on the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many. We're about 6 minutes away from totality in Iceland.
Yeah.
What do we expect to see right before totality?
Right. So right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world because right now they're on almost 24 hours of sun. So they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona.
Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total. That was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things for Iceland.
Okay. So we're seeing right now on screen a live telescope view from Spain, and that's because the telescope views in Iceland are obscured by clouds. But as Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
Right, anything can happen. And also, we'll talk about it a little later, but the balloon experiments, they are testing the atmosphere. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts with the sun and the light that we're getting from it. And you see, oh, we're starting to see something in the WB57. It's getting very close. They were zooming in there, so that's
okay. Oh, wow. Okay, so everyone who's watching right now, the right-hand box, you will see the live views from the WB57 aircraft. That's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me what are the benefits of observing the eclipse from up there?
From observing up there at 50,000 feet, wow, okay, so I'm looking at these are great. 50,000 feet, you're able to get above all the clouds. So they're above all the clouds, and we're able to, again, allow it to overtake us, so they get a few more seconds of totality. You saw that beautiful pink filament on the sun. That is something that Amir talked about, is that filament, that material that comes off the sun that can actually create space weather and affect our power grids here on Earth. It can affect our GPS, so if you ever use your maps to get anywhere, that's something that we need to understand and be able to predict. It also affects our astronauts, our dear astronauts, so making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB57.
Estas son gafas que son normales. Aguanta, mira, mira, mira. Vale, Guille, voy casi. Vuelas, Guille, ya. Vamos a medir el diafragma, espérate.
Nena, voy contigo, ¿eh?
Aguanta, vale.
Mira qué pepino de móvil que tengo.
Está fumando, tío. Mira aquí.
Estoy Guille con este. Estoy en este, Guille.
Sube un poco el plano. Voy contigo. Aguántame.
Iceland is still being covered with clouds, but totality will hit them in about just a minute or so. And luckily, our airplane, the WB57 aircraft, they're going to be getting clear views of the eclipse from the skies. So we're going to be seeing what the camera on the nose of the plane will be seeing in roughly 1 minute, which is so exciting for them.
So exciting, yes, definitely. And you are starting to see some of the what would be a diamond ring effect. So those little pink things that you're seeing, this is happens when light passes through the valleys of the moon. So you don't have a perfect circle in the moon. It has those craters, and there's that diamond ring effect.
Oh, wow.
So yeah, so just absolutely beautiful. And that's when you still should have your glasses on. And when that ends, that's when we're able to do it. And I want to comment, this is an experiment, right? And so this is part of the reason why we're seeing kind of the arrows or the crosshairs go in and out. We are real time, this is real time live. How science happens is that we are trying to make sure to make adjustments and make sure we're getting an image.
Wow.
Yeah.
So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the Nationwide Eclipse Ballooning Project. They've been launching balloons for the past 24 hours leading up to this eclipse, which is so exciting.
¿Estoy, Guille?